evolution of Open RAN and energy efficiency. Charles, you have about 20 minutes. If you'd like to entertain questions, please skip maybe a minute or two. And so I have the pleasure of introducing Charles Santhosam. He's the Associate VP at Mavenir, but he has distinguished careers in the past. He has a master's in engineering from Indian Institute of Science, an MBA degree. He also has worked in the past in Center of Development of Telematics. I actually met Charles in the Bharat 60 Summit a few weeks back when I was there. He also worked with Alcatel-Lucent, HCL Technology, and Parallel Wireless prior to joining Mavenir. He's a senior member of IEEE, and he was a speaker as well in many conferences. With that, Charles, is all yours. You got 20 minutes, so try to manage within that time. Thank you.
Thanks, Ashutosh, for the opportunity. Yeah, I'll share my screen.
Yes, please do. I'll stop sharing. Yeah.
Do you see my screen on the video?
It's coming up. Yeah. Can you just put it on full view?
Is that okay?
Yeah, that's good.
Okay. Thanks, Ashutosh, for the opportunity. So, compared to some of the previous slides, you might see this slide deck a little boring and probably plain and a lot of text. I must confess that I'm yet to get used to the ChatGPT kind of AI, generative AI tools to create a Jassy or a presentable slides. So please bear with me. And unfortunately, I couldn't travel. So I'm taking this session remotely. Hope it's useful for everyone. So with that, let me get to the agenda of the session. So basically, I will go over how the Open RAN is taking us towards the TCO, or in terms of the total cost of ownership and in terms of efficiency. It has multiple facets of the achieving that TCO. One of them is the vendor diversification and Capex optimization. The next step is towards OpEx optimization and the energy efficiency. And last but not least, the InterVideo interface that's being standardized in ORAN, which is going to provide the operators with the flexibility to go with multiple vendors of RAN software within the same site or same particular circle. Okay. So this is just a brief view of how the traditional RAN looks like and how do you purchase, how an operator goes and gets the equipment from a vendor who is providing the entire solution. And the color code just indicates that probably all these hardware, platform software, and the applications are curated, and the combination is chosen by the traditional vendor, and the operator doesn't have too many options in terms of picking up what is right for them, what is suiting them with respect to their requirements, and so on. So this is the starting point from where the Open RAN has started playing a big role in terms of opening up this vendor ecosystem and making sure that the operators have a lot of flexibility in terms of picking each and every component. So in this journey, of course, the entire journey of multi-vendor ecosystem does not happen on a single day. It requires a lot of effort, and it requires a lot of players to come together and contribute to make it happen. So one of the first and foremost thing that happened in the Open RAN standardization was the opening of the front hall interface. So if you look at the front hall interface, the CIPRI got replaced with eCIPRI. That brought in the room for any vendor, not a custom hardware, which can come in as a front hall gateway module. And also, because it is an open front hall and it is interoperable, the radio vendors can be anyone compared to the RAN vendors. So what it really helped is to split the two major portions of the entire RAN network into completely independent portions. If you look at the radio constitutes more than 2/3 of, or even probably 70-80% of the cost of the particular cell site. So by giving flexibility of choosing the radio vendors, or even to go with an existing radio vendor and you come up with a new Open RAN CUDU radio, vendor to interoperate with that radio is a huge flexibility for any operator to go with and embrace. So with this, the front haul switch, there are a lot of players, including the radio vendors that I have in the last slide in terms of the radio vendors and the front haul switch vendors. I've just taken the switch vendors here. So as of today, this is one of the first steps that we achieved in the journey of open front haul. In the Open RAN. So by now we have already integrated more than 10 radio vendors as part of the Mavenir Open RAN solution, and more than 30 plus radio variants, including bands and antenna combinations, power combinations, and so on. So, which means so we can interwork with several different radio vendors with our software, including our own radio, which can interwork with any other vendors' RAN software. So the next comes the virtualized and Open RAN solution, wherein you decouple the application software, where you decouple the applications. Sorry, there's a where you can decouple the application software from the platform and the underlying hardware, which means the operator can go and choose what type of server hardware they want and what type of the platform software vendor they want to choose, and pick up the radio or RAN software vendors independently. So, here we have already interworked with several of these hardware providers like Dell, HP, and Mitag. And similarly, the hardware could also come from private players or from cloud providers. And the platform software, for example, is coming from VMware, Google, and Red Hat, and Wind River kind of solutions. So with this virtualization and being able to have a RAN software that works seamlessly across different platforms and across different hardware platforms and software platforms, so it opens up another level of vendor diversification and opportunity for operators to choose what is the most suitable one for their network. Next step was mainly about how from virtualization, how do I go to Capex optimization? So there are multiple ways of optimizing the Capex. One is to choose a vendor who is friendly to you and whom you have already worked with in terms of the server hardware. So you can negotiate better, you get a better deal in terms of the hardware cost. The other opportunity is to convert the Capex expenses to an operational expense in the form of going to a cloud provider, and renting the compute from a cloud service provider. So that way, the huge part of the capex in terms of the servers and COTS service is taken away from the operator's bucket, and it gets converted to an operational expenditure. Of course, it may not be suitable for every possible operator, especially the operators who are very huge and who deal with the bulk purchases in terms of the servers. But for smaller players who don't want to get into the headache of maintaining a data centers or maintaining a huge number of servers and then taking care of the upkeep of all these servers, so they can always go to a cloud service provider and take the hardware for operating their network out of. So again, there are multiple cloud providers who can enable this, and the cloud network could be either private or public. So which means the public cloud is more of rental basis, whereas the private cloud could be owned by the operator, or it could be owned and operated by system integrators like Mavenir and other companies. So it gives a lot of immense flexibility in terms of how you build your network, in terms of the capex, and in terms of what platforms you want to use, how you want to do the automation. For example, the whole infrastructure automation depends on what kind of platform software you're using and what kind of tools you're going to use. By decoupling the complete infrastructure layer of it from the application layer, so the flexibility is you continue to utilize whatever is the infrastructure automation tools that are existing with the operator already. For example, the entire core might already be in a containerized solution where they are already employing the kind of automation tools to deploy and manage the lifecycle management of all the applications which are running under the core. Now the RAM comes in with the as an additional components. So the same set of automation scripts and automation tools with the same platform software provider, you can continue to integrate the RAM applications as well into the same network. So you don't have to manage multiple different networks or data centers for each of the parts of the component, parts of the entire network. So here I've just shown the LSC3 profile just to show that, the next level of optimization is about getting the cost optimized on the cell side. So let me go to that. So when it comes to the, there are multiple ways of optimizing Capex as we discussed before. So one of the options is also to see DRAN versus CRAN. The previous slide, what I've been showing is about optimizing the Capex in a centralized RAN case where the complete DU, CU, and entire network components are in a data center far away from the cell site. So which means, the Open RAN specification talks about up to 160 microseconds of latency on this front-haul interface. So which, when you're using a dark fiber, it translates to about 30-kilometer distance. So which means a data center a single data center hosting CUDU at a centralized location can cover a radius of almost 30 kilometers. And the sites which are falling within that 30-kilometer radius with much ease. And this kind of network and architecture is very much possible and feasible when you have a very good fiber network from your centralized data centers to the cell sites. The main reason for that is that the front-haul is heavyweight in terms of the data and the throughput requirements. So when we talk about the front-haul being run for about 30 kilometers, which means the data rates on this interface between the DU and RU can go all the way up to 100 Gbps when it comes to 100 megahertz 64TR kind of radios with 3 sectors and fully loaded kind of scenarios. So this means that you need to have the fiber connectivity from the data center to the RU. But there are regions where the fiber connectivity is a challenge, and you need to rely on microwave backhauls or any public domain internet connectivity with a leased line or leased pipe capacity of a very small bandwidth. Then the Open RAN architecture lends itself to that kind of a requirement as well. For example, regions in India where many of the sites are today connected through microwave and through low capacity low capacity for internet connections. So you migrate the DU to the cell site, which means the front-haul heavyweight front-haul is local within the cell site, and the CUDU interface, which is the F1C and the F1U interfaces, are not that heavy compared to the front-haul interface. But
Charles, you have about 5 minutes.
Yeah, thanks, Santhosam. So when you migrate the DUs to the cell site, you also need to talk about how do I reduce the overall cost of the cell site. So one of the major advancements that happened in the recent past is about the network interface cards, which can provide PTP and SYNC kind of capabilities. So which means I don't need to have a separate switch, which is and also I don't need a separate grandmaster at the cell site. So this removes a huge cost out of the cell site hardware budget. And a few examples I've quoted here. One of them is the WPC card, and the other is the Logan Beach card. Both are coming from Intel. In terms of the interfaces, they can provide 4 or 8 interfaces at the cell site. And they do have an integrated GPS receiver plus the PTP and SYNC capabilities. I mean, how do I go further? I mean, so the previous slide talks about a case where you have a configuration where you can manage everything within a, say, for example, a 32P core or even 2 server configuration. But there are operators who have multiple layers and multiple, even 200, 300 megahertz of bandwidth with massive MIMO kind of capacities. So for such cases, having everything in the software becomes too expensive or too many servers to be managed at the cell site. So one of the natural ways to progress is to offload something that is very much compute intensive. So when you look at the DU, the 60-70% of the compute is contributed by the layer 1. So by offloading layer 1 to inline accelerators, so you basically reduce the capacity of a given server by 2.5 to 3 times. So which allows you to keep the number of servers required in a cell site within 1 or 2 servers, and at the same time provide a huge capacity improvement at the cell site. So, for example, some of these cards play a dual role. They can act as a NIC card as well as the L1 offload because they come with internal inbuilt up to 12x 25 Gbps interfaces for the Ethernet. So, which means you basically replace the L1 and the NIC cards at the same time with a huge capacity and a reduced cost. So we talked about Capex optimization, and we also talked about OPEX. When we go to the OPEX in terms of energy is the huge OPEX component for any RAN network. So if you look at within the cell site hardware, 60 to 70% again, the power is consumed by the radios. And so the predominant component where you look for energy efficiency is on the RU side. So most of the initial work has been happening on the RU side in terms of how do I reduce the power consumption. The first thing is about the micro DTX is more of a symbol by symbol. How do I put the radio into low power mode when there is no data to transmit in a given symbol? Which means it goes to my granularity of almost like 35 microseconds in case of 30K subcarrier spacing and 77 microseconds as the granularity of putting the power radio into low power mode. And the ORAN standards have also evolved in terms of improving this sleep cycle. The initial versions had provision to sleep only up to a maximum 1 slot duration, because it just says for that slot how many symbols are empty. But in the release 10 and release 11 of Open RAN specifications, there are additional enhancements to increase the sleep duration beyond 1 slot and extend the sleep duration in the RU, thereby increasing the power, reducing the power consumption greatly. Once you achieve these two things and the traffic still goes down further, you go into something called a MIMO reduction. If there is only one carrier, you have put a 44-hour radio, but you really don't need a four layer worth of capacity in the site. So you can always reduce the cell site capacity to T2R and from 44-hour. Thereby, you can completely shut down 2 power amplifiers in the radio for that duration of the low traffic condition. And when you have a multi-carrier sites, you go in for a carrier shutdown, thereby you can shut down all the 4 power amplifiers for a particular band, as long as you have other bands which can cater to the traffic. And the other way the RU power is being attacked is migrating from FPGA-based to ASIC-based radios. As we move towards our Gen 2 radios, we are looking at integrating ASICs to reduce the power consumption on the radio side. So when it comes to the RAN side, primarily it's all in the software domain. So you can see that the C states and P states are some of the states in which you can put the CPUs in a low power mode, and in a given CPU of multi-core, each core can be selected and put on a different state. And the inline accelerators, again, help to reduce a lot of energy power consumption because the software compute is always expensive in terms of power consumption for the same amount of compute. So by moving some of the compute intensive functions to inline accelerator using ASICs, you reduce the overall power consumption of the cell site. And by migrating to microservices,
you have about a minute, just 1 minute
sure.
left.
Yeah.
Thanks.
So by migrating to the scalable architectures using microservices, you can shut down the scalable units. Thereby, you can reduce the number of servers that are operating in a low traffic hour. So that way, you still get energy efficiency at the data center or even at the cell site. So again, see these are at a node level. You can improve the power by doing certain features. And RIG, when it comes to RIG, it has the visibility of the entire cluster of say 100 sites or 1,000 sites, and it can do a lot more intelligent ways of reducing or utilizing these features to improve the energy efficiency. So last but not least, the one important feature that we are working on is the InterVideo Interface, which is basically allowing, I mean, today, if you look at 3GPP standards, there is no interface between two DUs, which is mandatory for any carrier aggregation between two different VDUs. Because there is no standardization today, we cannot perform carrier aggregation when you have RAN software coming from two different vendors. And each vendor have their own proprietary way of connecting multiple DUs, which is not amenable. By standard, I mean we have made proposals and ORAN Forum is working towards standardizing this interface, which will allow the vendor to even bring in, which will allow the operator to bring in multiple vendors within the same site, even though you want a carrier aggregation between bands A, B, C, and D. You can still have CUDU coming from two different vendors, and then you connect them through the interoperable InterVideo interface that is being standardized by the ORAN Forum. So this allows operators the flexibility to bring in at any given time. You can always go to a new RAN vendor instead of sticking to the vendor who is currently serving that particular cell site. Especially when we need to do the carrier aggregation on newly added bands along with the existing bands. So this has greatly reduced the vendor lock-in and allows the freedom for operators to choose whenever they add new bands. They can always choose the vendor at that given moment rather than pre-planning it at the time of starting up the cell sites. This is just briefly taking the overall evolution path which we have gone through. And this is probably you might have seen on LinkedIn from John Baker. This is the kind of Open RAN ecosystem that covers all the players in each of the domains, including alliances, operators, radio vendors, CUDU vendors, RAN intelligence, RIG vendors, and the platform vendors. So with this, I thank you for patiently listening to me. Have a good day. Thanks, Santhosam.
Thank you very
Over
much.
to you.
I don't know, this thing, microphone is working. Thank you very much, Charles. Interesting talk. I wish we had a little bit more time. So let's thank the speaker. I know we have about 200 people online, and we have folks on site as well. Thank you again. Let's give a big hand to Charles.